Hello, welcome to another pre-recorded lesson. The last topic we did was binary addition and subtraction, and today's topic, in this video anyway, we're going to be doing octal and hexadecimal addition and subtraction. So really I should have added that in here. And the process is very similar. We're still dealing with the same sorts of ideas where we add things, we're going to end up carrying into the next column. But in the case of octal, we carry whenever a sum exceeds 7. And in hexadecimal, it's whenever it exceeds 15, because 15 is our highest number for a single digit in hexadecimal, and 7 is our highest number for a single digit in octal. So for example, if we took the numbers 6 and 5, when you add them together, 6 and 5 added together in decimal is 11. That definitely exceeds 7. In octal, it's going to be 1, 3, which means we have 1, 8, and a 3. Remember what the place value means. 1, 8, and a 3 is 11. That's why they match up. So in any case where we're going to be adding, for example, we already have 7. As soon as we add 1 to it, we need to go into the next column. We need to be carrying. Same story with hexadecimal. If we get over and above 15, we have to be doing this carry operation. In hexadecimal, this is what all the numbers add up to if you add two single-digit numbers. The biggest one possible being 1e when you add f and f. If you want to pause the video and keep that table as a reference, or take a picture of it, screenshot, whatever gets you through, you can put that as a reference for yourself, because your printed notes might be too small. Who knows? Just do what's easier for you. Let's try some examples so you can see how this stuff works. So the first one, 5, 6 plus 4, 1. So 5, 6 plus 4, 1, both octal numbers. Let's see what we get. 6 plus 1 is 7. All right, that's not bigger than 7. That is 7. That's fine. So nothing to worry about there. 5 plus 4 in octal. Well, some students are like, well, that's 9, and they think they're done. But it's not 9, because 5 plus 4 is actually 9. That would be a decimal number. In octal, that number is 1, 8, and a 1. Remember, an 8 and a 1. So in octal, it's the number 1, 1. And if you want to double check that, 5 and 4 in octal give the number 1, 1. So the way that we write this is that we put our 1 here, and then we put our next one in the following column. There's nothing left to carry over. If there was a number there, we'd kind of have to toss it up there, and we would put the 1 there. But in this case, I'm not going to write that. So that's how this works. That is our final answer in octal, 117. 5, 6 plus 4, 1 is 117. Not decimal, doesn't have anything to do with decimal. So try to forget what you know about decimal when you're dealing with octal. Next example, 3, 7 plus 1, 7. 7 plus 7 in octal. Well, a lot of students say, well, that's 14. It's not 14. 7 and 7 in octal is 1, 6, because the number 14 in decimal is 1, 8 and 6 ones. So we have a 6, and the 1 gets carried over, and now we have a 1 plus a 3 plus a 1 gives a 5. 5, 6. So our final answer is 5, 6 in octal. So if you're having trouble understanding what I'm doing here, rewind, bring the video back, watch it again, try to make sense of it, because we're going to be using these concepts again. And just for the last time here on this page, the 7 and the 7 added together gave us our 1, 6, which is where this came from. Just try to connect all that together, okay? Let's move on to another example. This one is octal subtraction. So if you're a bit shaky with your addition, make sure you got that before you move on to subtraction, or you'll just get confused. 3, 5, 6 minus 1, 4, 3. Okay, let's think about what we're going to do here. When I look at this, I see that all the numbers on top, when you look at the columns, are bigger than all the numbers on bottom. 6 is bigger than 3, 5 is bigger than 4, 3 is bigger than 1. And so the column subtraction is going to be really easy. 6 minus 3 is 3. 5 minus 4 is 1. 3 minus 1 is 1. And so there was nothing to do. That is our number in octal. We could find a decimal equivalent if we wanted to, but this is all the question is asking. And that's it. There's nothing to do. There's no borrowing. So there was no borrow here. Borrow means you have to take a number from the next column over. Let's try the next example, a little more involved. Looks similar, quite a bit more involved. right off the bat here, 6 is bigger than 7. And so we can't just put a -1 there and call it a day. We actually have to steal from the previous column. So we take 1 from that previous column and make it 5, just like when we did it in binary, just like what we do in decimal, regular. But that place value is an 8. This is octal. Remember the place values. If I just make a little chart here, our place values in octal are 1, then 8, 64. And if we keep going here, we would have how many 512s we have, and we'd actually have how many 4096s we have. But generally speaking, for this process, we actually only care about these first 2. And the reason I'm talking about this is in the world of these numbers here, this column here is the 1s, this column here is the 8s. I've stolen one of our 8s from that second column relative to this column. The next column over is the 8s column. So when I steal a number or I borrow a number, I have to add 8 to this column here. Okay, this is the key. This 8 is absolutely crucial. You need to know why you take an 8. And it's the same as binary. Remember when we dealt with binary? Let me think see if I can come up with an example. Yeah, just say we had these numbers in binary. If I wanted to do that first subtraction, I can't do it unless I borrow from the previous column. It brings it down to 0, but it gave us a 2 because the place value of the next column is a 2. And then we say 2 plus 0 minus 1. So we add them together, 2 plus 0 minus 1 is 1. And that's an intermediate step. That is a decimal thought in the middle of an octal subtraction, but it helps us do it quicker. It's kind of a shorthand. All right, so going back to our octal example, we can, let me just say, I had the question again so that we're clear. 6 minus 7, I needed to take 1 from the 6, and it gives 8 to this column, and then those two are going to add, because that's really what I have in total now, 8 and 6, and then minus 7 is a 7, and back to normal. So when you're doing this step here, you can put it all on your calculator or do it all in your head, 8 plus 6 minus 7. It's always going to spit out an octal number. The final answers here after the subtraction will always give octal numbers. So you do a little decimal side in the middle, but at the end you're going to end up with your octal numbers on the final line, so we're safe. Same situation here. We've got a 5 minus a 6. We're not allowed to do that. So we borrow from the next column, brings it to 2. It gives an 8 to the first column. Remember, we stole a digit from the 8's place value column, which gives us 8 in the 1's column. Now we have 8 plus 5 minus 6, which is 7. Next column's easy. 2 minus 1, 1. So 177 is our final answer. If you didn't follow that, you need to watch the video again because it can be quite dense. But I'm going to be doing some hexadecimal stuff next, and I believe, yeah, we do quite a lot of examples of hexadecimal. So rewatch that video if you need to. I'm going to move on to hexadecimal now. Hexadecimal, same concepts, but we have more going on because, of course, we're now dealing with 16 different numbers, everything from 0 to F. We're not just going up to 7. Let's see what they look like. 217 plus 1A5. And the reason I put this guy over here, laughing at you, you might recognize him, is this is probably too small for you to read. But if you want to recognize it, if you want to remember it, you can bring this up here, take a look at it. I recommend that you probably make a big version of it on PDF and print that. Put it in front of you or something. Sorry, I'm trying to get the zoom right. Okay, let's do this. 7 plus 5. 7 plus 5 is 12, but 12 in hexadecimal, well, sometimes students find this easy to do. They, on their page, every page, they have to do these calculations with hexadecimal. They'll write down what the decimal number is and what the hexadecimal number is. And many students find that very useful. It's useful to them because they don't need to do it in their head as much, right? So 7 plus 5 is 12, and 12 in hexadecimal is C. So we get a C here. Hopefully you can figure out why that is or make some sense of that, we're allowed to put 15 different numbers in a single space, which is why hexadecimal is so useful. In the next column, we have 1 plus A. A is 10. Right? A is 10. So it's really 1 plus 10 or 11, and 11 is B. So there's going to be a lot of highlighting here, but I'm trying to connect them. 1 plus A is the next digit after A, or B. So we get B out of it. And the next column, it's 3. So 3, B, C is our answer. For our next question, I have a feeling we're going to need to carry. Let's see what happens. 245 plus 2DA. 5 plus A is the same as 5 plus 10, which is 15. 15 in hexadecimal is F, so we're okay, we didn't need to carry. 4 plus D, that's 4 plus 13. 4 plus 13 is 17. Well, we can't do 17. 17 in decimal is actually the number, let me think now, 15, 2 more than 15, so 2 more than A, 1, 0, 1, 1 in hexadecimal. Or go 4 plus D in your table. I know it's very small for you, but 4 plus D gives us 1, 1. And so our answer is 1, 1. Again, I'm just going to play this Zoom game, sorry. Okay, 1, 1. That's exactly what I got. So rewind the video, watch it again if you need to. What that gives us, we can't just say 1, 1 like this, because it doesn't work like that. So we can put the 1 and the extra 1 that we have, we'll have to go on top of the next column. And they'll just add up in the end. So it'll be 1 plus 2 plus 2 is 5. So the final answer here is 5, 1, F. And I recommend that you check these answers by using some sort of converter, okay? Or check it on a calculator. For example, let me just, as a side note, check my first one. All right, by changing it to decimal. You can check it by doing expanded form for each. So 217 in hexadecimal is 2 times 16 to the power of 2 plus 1 times 16 to the power of 1 plus 7 times 16 to the power of 0. And what that would give us, 2 times 16 to the power of 2 plus 16 plus 7 is 535. All right, the next one, 1A5 in hexadecimal. It's going to be 1 times 16 squared, 10 times 16 to the power of 1, plus 5 times 16 to the power of 0, or 5 times 1. What that's going to give us is 1 times 16 squared, plus 10 times 16, you should be trying this yourself, plus 5, that's 421. And I'm almost to where I want to be. I'm going to add them together to see what the decimal is. That's 421. If I add that together, 535 plus 421, that should give me a nice 956. And then I'm going to take this answer here that I got, 3BC, change that into a hexadecimal number, sorry, a decimal number, and see if it's 956. And if you really want to, you can skip this. I'm just showing you how you would check your work longhand, but it's not absolutely necessary. Just one way to check your work. And let's see what I get. Moment of truth. 3 times 16 squared plus 11 times 16 plus 12 times 16 to the power of 0, it's 956. So I've convinced myself, and hopefully you as well, that doing hexadecimal addition is just as legitimate as converting to decimal first and then checking it, or converting back, but doing the huge conversion process is way more work than just learning how to add them as they are. Okay, so sorry about the little glitch in the middle there. I just had to fix something in my recording. Now that the addition problem's done, I'm going to do 4 hexadecimal subtraction problems, and hopefully by the end of that you'll be experts, or at the very least you'll have a clear understanding of how this process works, and you'll just need to practice. So the first one, C84 minus 562. These are both hexadecimal numbers. Let's see what this comes out to. Well, I have a similar situation as before with octal. All these top numbers are bigger than all these bottom numbers when you look at each column. So we're not going to need to borrow at all. 4 minus 2 is 2. 8 minus 6 is 2. C minus 5, well, let's just compare here. C is 12. So it's the same as 12 minus 5, which is 7. So that answer pops out really quickly. The next question is going to be a little more involved. 974b minus 587c. And we can see here we have a bit of an issue. Every one of these numbers is bigger than every one of these if you look at each column, so we're going to need to do some serious borrowing going on here. Okay, let's get to it. B minus C. Well, I can't do B minus C because that would be like saying 11 minus 12, and 11 is smaller than 12. So we need to borrow. So if you followed with Octal, this should be pretty simple for you. It gets decreased by 1, and the next column, the first ones column, gets 16. The reason it gets 16 is the same reason as before. If we look at a single set of two columns where the place values are 1 and 16, if we steal something from this space and give it to the ones space, it gives us actually 16 things to work with in that space. So that's the main idea why we are allowed to steal 1 from the 16s column and we get 16 from it. It's because that's exactly what we've done. We stole 16. Then what we do, we add these together. Again, don't change the 16. I know that it's not a hexadecimal number, but this is shorthand to try and help us. So 16 plus b, that means 16 plus 11 minus c, c being 12. So it's going to really be 16 plus 11 minus 12 is kind of the situation we've got here. So take some time to think about that. That gives us a 15, which is actually f. So that's a lot of stuff going on in one step. But let's think about it clearly. Anytime it has a letter, we need to think of it as a number first. So it's 16 plus b, b being 11, then minus c, c being 12, which is 15. 15 is f. I'll write it out one more way. I'm just dealing with this first column, okay? Just this column here. It's the same as saying 16 plus b minus c, which is the same as 16 plus 11 minus 12. And 16 plus 11 minus 12, once again, is 15, and 15 is f. So I wasn't kidding when I said this is going to be more involved. There's a lot of thinking, but once you get good at this, it becomes second nature. Let's do the next column, 3 minus 7. Can't do 3 minus 7, so we steal 1 from the next column, we borrow, we add 16. Now we're going to have 16 plus 3 minus 7. 16 plus 3 minus 7 is 12. We're not allowed to have 12. 12 is c. So we write c. Let's move on to the next column. 6 minus 8. Not allowed to do that. So let's move on. Steal or borrow from the next column. That's a 16 here. We have 16 plus 6 minus 8. That gives a 14. 14 is e in hexadecimal. And then the last column, 8 minus 5. 8 minus 5, you should know, gives 3. 3ECF. We're all done. So lots and lots and lots of thinking going on, but it's a very logical process. It follows an algorithm. It's the same thing every time. We did the same thing in binary. We did the same thing in octal. The only difference in hexadecimal is that we're dealing with these letters. So when you calculate using those letters, change them to the actual letters so you can make sense of them, and then at the end, you convert back. I'll do some more examples. Actually, we'll do one more example. So this example is FC4 minus 2C7. And once again, we're seeing that we're going to have kind of a negative situation. 4 minus 7 can't be done. So right away, we're going to need to be borrowing. So let's do the borrow. 4 minus 7, borrow from the next column. It reduces by 1, gives us B. Why is it B? Well, because the letter before C is B. Or it's the equivalent of saying 12 minus 1 is 11. Well, C minus 1 is B. All right? It gives us 16. What do we do? Remember, when we have a carry here, or we've borrowed, I should say, you add them and then you subtract the 7. So it's 16 plus 4 minus 7. That gives a 13. What's 13? 13 is D. So write our D. I'll write it out to the side. Remember, it's the equivalent of saying 16 plus our 4 minus our 7. That would give us, again, 13, which is actually D. All right? Whatever way works for you. Try to get some sense of this. Try to do some practice. Do it on the side, whatever you need to do. Next column, same story. Can't do b minus c. b is smaller than c. Borrow from the next column gives us an e. That gives us a 16 in the ones place. When we're dealing with just a single set of two columns, we can think of it like that. And then once again, 16 plus b, which is 16 plus 11, minus c, which means minus 12. So 16 plus 11 minus 12. That gives 15. 15 is f. Hopefully you can see the logic in what I'm trying to tell you here. Finally, e minus 2. E is 14. 14 minus 2 is 12. So it's 12, or the equivalent would be c. C, F, D. Woo! All right. Let me do that last column for you by hand. We want to do e minus 2. E minus 2 is the equivalent of 14 minus 2. 14 minus 2 is 12. 12 in hexadecimal is the equivalent of c in hexadecimal. In fact, sorry, that should be 12 in decimal is really what we're thinking about. Gives us c. Okay? So take time to make sense of this. It's extremely important that you take your time to practice, or else you're going to get all jumbled up between all the systems. I'm just going to move on to show you what the very last thing is saying here. It's saying multiplication and division. All right, let's get it. Let's get to it. What does it say? Multiplication and division of these numbers is not included in the learning objectives for this course. Okay, good, nice. So Mr. Squirrel knew this ahead of time. He's been just like celebrating for the last week. He's exhausted, but he's happy. All right, no multiplication and division. On the assignment, you can skip that question, or you can do the question on the assignment for a bonus mark. But I'm not going to explain how to do it. Very last thing it says here, there is extra practice with addition and subtraction on D2L. So on D2L right now, these worksheets should be there, and you can go find them, you can go download them, print them off, or just do them, have them in front of you, use a piece of paper to solve them. The answers are all included as a second page. So you've got binary addition. Let me just zoom in on this. I know it's quite small, so I don't recommend doing it on this page. You've got binary addition and subtraction. You've got octal addition and subtraction. And you've got hexadecimal addition and subtraction. If you don't want to go ahead and go find it on D2L, you can just pause the video here and do this work on a separate page. If you were to do all of these problems, no one's going to be able to touch you for this stuff. You're going to be king of the addition and subtraction of number systems. Boom, I'm over here now. Actually, the reason I added this to the video is I looked on D2L, and the worksheets that are up there are actually slightly different than the worksheets you see here. So if you wanted to work through them as you see on this page, you can do so, but the answers won't be provided. The ones that are currently on D2L are essentially the same questions, just different numbers, and they do have full answers included, so you can take a look at that. So good luck with your arithmetic, and I have a feeling you're going to master this in no time flat. There's one last thing in this chapter, or unit, and that's the final section, which is applications in computing. And it says that you need to read the associated module on D2L. It's just one section on D2L that I expect you to go through yourself. It's kind of like a reading assignment. Go through yourself and try to understand basic information from the section. And it will be expected that you know some basic information from this for your assignment, especially your assignment A, part A, the online quiz part. So what it says here is when you're finished reading, you should at least be able to answer the following. So these are questions that would be really important for assessments, for example, definitely things that I would ask from, but you need to know at least this, and hopefully you would know more. So what's a bit, what's a byte, and so on. All these questions need to be answered by you. I'm not going to be taking them in as homework, but they're something that you need to know yourself, so make sure you cover that. And that's it for this unit. You can see that all that's left is the key terms and concepts, which you should take a look through. Make sure that you do indeed know how to do all of these things. This is a good thing for when you're preparing for a test, for example, to say, do I know what a number system is? Decimal, binary, octal, hex, what's the difference is? And for example, if I asked you to describe and express a hexadecimal number in expanded notation, you should know how to do that. All right, and that is it for this video. Have a great day, and we will see you soon.